Hi, my name is Adrian Stanley. Ever wondered why you were hungry? Well, the obvious answer is that you haven't eaten in a while, but it goes a lot more deeper than that. I wanted to explain here in this video exactly how starting from the moment you eat food, how it makes you not hungry, and why lack of food makes you feel hungry. So basically, the basic what you generally feel when you haven't eaten in a while is you haven't eaten in a while and you start to feel hungry, and eventually you eat food, and that food will fill your stomach, and eventually you're not hungry anymore because you've eaten. As time passes, eventually you've digested all that food and you'll feel hungry again because your cells need more energy. Knowing that, I want to explain the basic way that that feeling is induced, that feeling of hunger. So first thing I have to start explaining is the hypothalamus. So basically, your hypothalamus is going to be a key area that's going to be responsible for your feeling of hunger. So the main areas I want to focus on in the hypothalamus are the paraventricular nucleus, the lateral hypothalamic area, and the arcuate nucleus. The paraventricular nucleus basically is associated with your stress response. So basically, when you eat, whether you're eating food or not eating food, it's going to have effect on your stress systems, and I'll go into more specifically how it's affected in a moment. The lateral hypothalamic area, this is the area that's going to stimulate hunger. So the lateral hypothalamic area plays a critical role in the feeling of hunger. The arcuate nucleus, basically it acts as a sensor, basically, so it can sense when you're not eating a lot of food. It can sense that, and I'll explain exactly how it senses that in a moment. Alright, so whenever your stomach is empty, you have mechanosensory neurons in your stomach, in the walls of your stomach, that sense when your stomach is empty. So because of this, those neurons will signal the release of this molecule called ghrelin. So this ghrelin molecule will be released into the blood, and eventually it's going to float in the blood up to the part of your hypothalamus called the arcuate nucleus of your hypothalamus. So ghrelin will float in the blood up to your hypothalamus, and it'll reach a part of your hypothalamus called the arcuate nucleus. So in the arcuate nucleus, it'll bind to receptors on those neurons, and these neurons in the hypothalamus, in the arcuate nucleus that ghrelin binds to, release these molecules called neuropeptide Y and AGRP. So these peptides will have different effects on other parts of the hypothalamus. So neuropeptide Y in the lateral hypothalamic area will stimulate feeding behavior. So if the lateral hypothalamic area is receiving a lot of input from neuropeptide Y and AGRP neurons, then the lateral hypothalamic area will release these molecules called MCH and oxorexins. So basically, these oxorexins will be released in your cerebral cortex. So the lateral hypothalamic area has neurons that synapse in your cerebral cortex, and the increase in oxorexins and MCH in the cerebral cortex is what stimulates your feeding behavior, because of course your cerebral cortex is involved with your thinking and your reasoning and things like that. So the neuropeptide Y neurons and the AGRP neurons that synapse in the paraventricular nucleus, these will inhibit the paraventricular nucleus. So the paraventricular nucleus won't secrete things like adrenocorticotropic hormone, which is a hormone that stimulates the stress response. So the stress response is inhibited in the case of elevated ghrelin levels when you haven't eaten in a while. Alright, so now that you've been made hungry by your lateral hypothalamic area, now you're gonna eat, right? So after you've eaten, then Eventually, food will fill your stomach. Then that food will eventually be moved onto your intestines, and the food will be absorbed. The nutrients from the food will be absorbed. And as your body and your cells absorb nutrients, it starts to store extra nutrients as fat. So as fat is stored, it's stored in your fat cells called adipose tissue. So when adipose tissue starts getting lots and lots of storage is happening in your adipose tissue, then it starts releasing this molecule called leptin. Now leptin is going to do the opposite effect, have the opposite effect as ghrelin. So basically, when leptin binds in the arcuate nucleus of your hypothalamus, the arcuate nucleus is now going to release these two molecules called alpha MSH and CART. So alpha MSH and CART will now inhibit the lateral hypothalamic area. So the lateral hypothalamic area never releases its excretins into the cerebral cortex, so you don't feel hungry. And it'll also stimulate the paraventricular nucleus of the hypothalamus, and the paraventricular nucleus of hypothalamus will then activate your sympathetic nervous system, and it'll also release adrenocorticotropin, which can stimulate the stress response. Alright, so in your lateral hypothalamic area, there's basically competition between the alpha MSH molecule and the AGRP molecule in the lateral hypothalamic area. So the AGRP molecule wants to stimulate the feeding behavior, while alpha MSH wants to inhibit it. Basically, there's this special receptor in the lateral hypothalamic area on some of the neurons there called MC4. So basically what happens is, when there's lots and lots of alpha MSH and it attaches to these MC4 receptors, then it's more likely to activate and stimulate feeding behavior. However, when there's lots of AGRP, the AGRP will want to inhibit the activation of this receptor and inhibit feeding behavior. So basically, these two molecules, they act opposite to each other on this receptor. If alpha MSH were to bind to this receptor and AGRP levels were to be high enough, it can also attach to the receptor and antagonize the actions of the alpha MSH molecule. So because of this, it allows for an opposite interaction between the leptin activity and the ghrelin activity. Right, so that's the main way that hunger is stimulated and satiety is also initiated. So basically, there are other ways that the satiety is also stimulated. When, for example, when food fills your stomach, basically the food from your stomach is going to get released into your small intestines, and this part of your small intestines, when it senses lots and lots of fat that's being released from your stomach into your intestines, it's going to stimulate the release of this molecule called CCK. CCK, the purpose of it is mainly to stimulate the release of bile from the gallbladder. So the release of bile from the gallbladder will allow bile to enter the small intestines, and the bile will help in the degradation of the fat molecules. So this CCK molecule, what it'll do is it'll bind to neurons on the vagus nerve. Basically, the vagus nerve is a nerve tract that goes from your body to the solitary tract in your medulla. So there's part of your solitary tract. There's a part of the medulla called the solitary tract, the nucleus of the solitary tract. And basically, what the solitary tract will do is it'll send a signal to your cerebral cortex, and it'll initiate satiety. So it'll make you feel not hungry. So CCK release from the small intestines will activate those vagus nerves, And another way that hunger is inhibited is once you've eaten and your stomach begins to expand, those same mechanosensory neurons that sensed when the stomach was empty now sense that it's expanded, and they'll stimulate the vagus nerve neurons to tell your medulla, to tell your brain that you're not hungry. All right, so that's the basic mechanism of how hunger is initiated in your brain. Thank you for watching. Feel free to ask any questions if I've said anything confusing. I'll try and clear it up. And thank you.